film would have to roll. And now there's no film. Well, there's still film depending on how people want to shoot things. All right, due dates for Khan Academy work are weird right now because it's due today. And then we're going to probably be trying to take your unit test next week. So I forget if I've gone ahead and assigned the next batch because Khan Academy crashed earlier when I was thinking about assigning it or not. And I'm afraid to say this, but I am planning to use today kind of as a work day. We can move forward if we want to and if we're able to, but some people aren't done with work that is due today. Actually, it's due in about 40 minutes, and that's concerning for me. So I would like to, for a moment, have everyone get out your devices and email me if there's anything at all you want to talk about. And some of our function work is starting to get kind of confusing. Like Sophia emailed me earlier with a question I didn't even realize was being asked of you. And I was like, oh, you don't know piecewise functions yet, which are also known as step functions. So some of you may have seen that one in your work already. Kelly?
I would like to say, no, you haven't assigned the next batch of homework, but you have assigned the January 19th unit test.
Oh, I went ahead and made it live? Yeah, that was my plan. If you are totally caught up on everything else, and I made it live yesterday right now at the beginning of class, so if you already started it, that's your prerogative. But you may work on the unit test right now. Please, if something needs written down, if there's work to write down work in your math notebook. Because, guys, it's easier to do the revision. If you have some work written down that we can look at together, it's easier to do the revision. This is probably the last Khan Academy test we really utilized for a while. We'll start doing most things on paper and pencil. Yeah, but some of the questions are like, what's the y-intercept? See, you can't really complain about the number of questions when some of them are...
Some of them are like, is this a linear graph?
Yeah,
it goes like...
You're proving my point. You can't really complain because it's not that bad. So right now, I should be checking my email for anything people are sending me. And actually, we can look at what people sent me yesterday as well. Before we did that, I did want to log into Khan and show one other thing and make sure that this makes sense to you guys. Hold on. I'm going to get distracted and forget. Where is it? Which one is the one that has you select linear or not and asks you the maximum y? Interpreting, yeah. Interpreting linear function? No, interpreting all functions, graphs of functions. Yeah, so I wanted to make sure that this assignment makes sense. This is what I tried to pull up right at the end of our last class, and then we ran out of time. So, guys, I just wanted to check that, as we're looking at this, we're not making it overly complicated, because I helped 3 different students that as soon as we started talking about this, they were like, oh, that's not that hard. So, is this linear? I don't even have to scroll down to tell you it's not linear. It goes up and then it comes back down. The hang time. This was kind of a weird question. What's hang time mean?
How long it's in the air.
Yeah. Thank you. How long it's in the air. Guys, remember, we're at school, so you can just talk. Unless I ask somebody specifically, say, hey, Nick, what's the hang time? We're just having a conversation, right? So it's okay. You can just talk. So the hang time would be how long it stays positive, right? In the air, it's positive. If it hits the ground, it's not in the air anymore. Maximum height is literally just the top of the graph. So in this case, it would be 11. When t is, so drop down to your t and find out it's about 1.5. Right? And then this is the sort of stuff that I think people are overcomplicating. Guys, it's just asking you if the graph is going up or going down, or if the graph is positive or if the graph is negative. So here our graph is increasing, but when we see other questions where it's asking us for a range, is the y greater than or less than? Let me see if the next one gives it to me. All right, so this is a good one. As x increases, what happens with our y? Decreasing. It's going down. It changes how quickly it goes down, but it's decreasing. The rate of change for y as a function of x is, no, it's not constant. It is changing. We can see it's curved, right? Curve means things change. Therefore, we are nonlinear. All values of x is a function of y. This is the sort of thing where kids are like, wait, what? And I was like, guys, it's just asking positive or negative. But it's making you do it the fancy way, right? Positive is greater than or equal to 0, although equal to 0 is not positive. Negative would be less than, right? Equal to 0 means it's equal to 0 the whole time. Well, for everything that we see, it's not negative. You know that. So should likely be greater than or equal to 0. We don't know if it's actually equal to 0, but that's why it's greater than or equal to. So yeah, that's like the review that I wanted to do on that to make sure those make sense. So I'm coming back to my email to check and see if anyone has sent me any screenshots in this moment. This is perfect. One of your classmates who's not even here right now just sent me a screenshot, so I think it makes sense for us to just go over that right now. So, right, literally, they must just be working on their math right now. It's probably still the interpreting graphs of functions, so I bet I can just do this. Trash took a slice of pizza out of the freezer, put it in the oven. I really don't think this would actually happen if we're really tracking real life things, but we'll go with it. So then the question they ask us is, how long was each increase by 4 degrees Celsius? A weird question because they're not looking for the unit rate. What they're looking for is how long was, did it take, right? How long was each increase by 4 degrees Celsius? Well, if we look for an increase of 4 degrees Celsius, wait, I can't see that from the graph. Oh, we're going to have to do some math. Go figure. So what we need to do is figure out what the rate is, and then we can use that rate to determine the 4 degrees Celsius. So let's find some points that work nicely. I don't know. Here, probably. 2 and 10, that's a nice point. 2, 10, sweet. If I want to, I can just come back to here too. Except that's 0.75. I wonder if I have a nicer one. 4.5 and 30. Yeah, I'm going to go with that. So guys, remember to talk about our rate, we do change in y over change in x. Zoe and anybody else watching the video, I apologize, you're not going to be able to see this. But if I look at this point here, 210, and 4.530, remember we can make the slope triangle. So we ask ourselves, what's the rise and what's the run? Well, our rise is 20, and our run is 2.5. Actually, you might be able to see it through that camera. So if we do that division, my calculator is going to stop working very soon. Keeps telling me the battery's dead. 20 divided by 2.5 is 8. 8 what? It's 8y per x. What is y? Degrees Celsius. What is x? Minutes. So it's 8 degrees per minute. Well, if it's 8 degrees every 1 minute, how long does it take for 4 degrees? Half a minute. Yeah, 30 seconds. So that is how we solve a problem like that, is we first have to compute the rate, and once we know the rate, we can apply it. We don't care about the y-intercept at all here. It's a tad bit ambiguous what it is down here. We don't care. It's unimportant. I am checking my email again. We can also go over stuff that people sent me yesterday like this. Anyone want to talk about how we write the function of something like this? Yeah, these problems got a few of us. So if we talk about Dominic's, oh, just general question. Yeah, go ahead, bud. Who's smarter than me? Kelly, I would look at you. Do you know how to work Macs? Darn.
My mom's got a Mac, my dad's got a Mac, I got a
I'm surprised you don't know how to work their computers, though.
No,
Hey, Google it. Like how to take a screen picture on a Mac.
They won't even let me touch them.
Or go to Safari and search it.
No, I thought it was something like that. I knew it was a command before, I just didn't know what the third key was.
I like when they make hotkeys that are like 5 different keys that you have to hit at once. And it's like, this isn't easier. This is like more difficult. So just by the way, talking about problems like this because it's up there and people had asked me about it yesterday. In these situations where we're being asked to determine what the function is, always ask yourself if you know where you start. Like, and why I'm saying this, why I think it's worth saying, is when we write functions, most people write the change and then write the start. That's backwards, right? We could, I mean, it's not backwards for how we write a function, but it's backwards for how we think. Dominic starts with 1,500 grams of filling. He then uses, so it will go down, 20 for every dumpling he makes. Right? Always think about what is the situation actually telling me. Right? What do we start with? What do we use? Or what change is happening? I'm going to do one more from yesterday, and then I will take the problem that just came into my email, and we'll do that. Oh, this is a really good problem too. And for the sake of it being in the video, I should probably stay here and do it up on the screen. So one of the things I wanted to make sure we talked about was which variable goes where. When we talk about a function, we talk about y is a function of x, right? So when we have y equals something times x plus something or minus something, we say y is a function of x. So when they ask us t as a function of g, we know t has to be alone. Or when they say, what they ask here, temperature is a function of x, that means temperature will be alone. X will have the numbers with it. So in this situation, we say, where do we start? 21. We start at 21. To find the rate, we talk about the change, and we do our change in temperature over our change in time, which our change in temperature is from 21 to 75. So that's 54 degrees. And our change in time was 12 minutes. When we compute that rate, we just get 4.5. Sorry, and instead of minutes, they actually use x, so I had to change my variable there. Same situation with the tokens, just because I already showed you this on my paper. If you look for the problem with the tokens, he starts at 20. We come to find out when we compute the rate that every time he plays the game, it costs 4. This just came in. I love these questions. Might come back to that one. Guys, I have a few questions for us to go over. What was the test that we talked about for determining if something is a function? Vertical line test. And what does the vertical line test say? Yeah, if a vertical line hits twice, it's not a function. Here, a vertical line would hit infinitely amount of times. It would be the whole thing. The vertical line would be the entire function. It's not a function. Sorry, so when we're sometimes we talk about something as a function until we decide, oh, wait, it's not. This is an equation, not a function. This equation is x equals 6. That's what this equation is. This is the graph of x equals 6. But that is not a function. It fails the vertical line test. Now turn it sideways and make it y equals 6, make it a horizontal line. That would be a function. A horizontal line would be a function because it can pass the vertical line test. This problem was just one that some people struggled with. Our initial volume, right? Initial volume of 32. The every item, our unit rate, is 0.05, right? So each marble is filling up some of the volume. It's taking away how much water you need. So it doesn't mean that the marbles have a negative volume. That doesn't make sense. It means that the marbles take up 0.05 liters for each marble we put in. This was a weird one. If anyone wants to talk about Tyrone snacking, I want to check my Gmail real quick. See if... Every time Tyrone snacks, he eats 8 pieces of candy. So one, I know, right? One snack time is 8 pieces of candy, right? So after eating 18 snacks, not 18 pieces of candy, 18 snacks, there are 6 pieces of candy remaining in the bag. How could I use this information to determine what the initial amount was? Yeah, and Kelly, that was probably, if you want to say it again. Could you hear from back there? Well, I just like these new classrooms that we can actually hear each other.
So you have 8, so multiply 18 by 8 to get the number of candies in the bag, and then subtract that from the number of candies left in the bag, or add the number of candies
Add.
in the bag.
Yeah. So,
Get the starting value.
did you do it?
Subtracting.
Did you do it? What's 18 times 8, then plus 6 to figure out the initial candy?
I don't know. 150.
You sure? Adam's calculating it in his head too. I don't even, it's 18 times 8 is 80 plus 64 plus another 6. Yeah, 150? Yeah. Yeah, I think it's with the extra 6. All right, so we have to do the 18 snack times. Each would have had 8 pieces of candy. This is where people got confused on this, I think. So pieces and snacks are 2 different things, right? Snack corresponds to 8 pieces.
So pieces are a function of snack, but snack is not a function of
Yes. I love pizza. All right. So this, I just wanted to talk about because it's a cool graph that only some of you got to see in your practice. This mathematically is what we call, anyone know? You're deeper than we need to be right now. You're not wrong, but that's math too deep. This is a spring that is, or maybe this one's not the spring, but there is a question in your con about a spring that is going like boing, boing, boing. Like a weight keeps pulling it down, and it keeps going back up. This is what we call, anyone know what a fan that goes back and forth is called? Starts with an O. Oscar the Grouch. No, it's oscillating fan. So this function is oscillating, going back and forth. And think about it like this. If you look at a clock, this might blow some of your minds, and you talk about the position of the hand And this is a function that you might actually graph at some point. You think about the position of the hand relative to the middle of, if we say that's 0, and that up here is a vertical height of 1, and down here is a vertical height of -1. All day long, whether it's a second hand, minute hand, hour hand, hour hand, you could argue, might not reach the whole way up, but you can see that the position will go from 1 to 0 to -1, back to 0, back to 1, back to 0. This is going to oscillate. So if we graph it out, it'd go up to 1, down to 0, down to -1, up to 0, up to 1. If we just draw the graph different, right? If we say what time of day is it, how high is the minute or hour or whatever hand, this is the sort of like interesting. Now, you might be like, why do we care about the location of a hand of a clock? Probably don't. But if this is like ocean tides, right? Ocean tides have this oscillating kind of continuous behavior, then we might start to care. Oh, this was a really fun question. So, especially if you haven't done, I think this came from interpreting also. Here, is the slope constant? No. Is this graph a function? Yes. This is a function because it could pass the vertical line test, right? So we want to talk about what the rate is in the first section of the rental. I know we can't really see it when I full screen it. Darn it, we still can't really see it. Oh, maybe if that drops away. It goes by 1. Every block is 1. Okay. So for the first 3 hours, figure out your slope. Rise over run. Well, 12 over 3, so $4 an hour, right? Our slope is $4 an hour. Sorry, I should really use a pen. Writing with my finger doesn't work as well. For the second set of time, so it got cheaper, right? So it's $2 an hour. And what about here? 4 over 4, that's actually $1 an hour. What's the slope here? $0 an hour. Guys, you're now not paying for time. You're now just, you get it for the rest of the day. Doesn't matter how long you keep it, you maxed out your cost. So this is a pricing model that would encourage people. Once I've already had it for like this long, like I maybe might as well just keep it the rest of the day. Like it's not that much more expensive. This is a bike rental, in case you didn't read the problem. Yeah.
It's like buying a violin, or it's like renting out a violin
Yep.
or an instrument where you rent it out, like every monthly pay gets cheaper
Yep.
until you just own the instrument.
Absolutely.
Once you pay for, like, I think it's 125% of what the instrument costs in the store, you get to keep the instrument.
Well, doesn't that make sense, right? You've already paid all of the instrument and then some.
Yeah. So,
Yeah.
Well, they have to make some profit.
Right.
I mean, you get to keep it for much longer and you get to space out the payments. It's basically like unequal payments on Amazon.
Right.
It's $5 more than normally.
So we technically have 20 minutes left. I technically have no emails from you guys in my inbox. So what I'm going to do is go check what assignments need done and what people might need help on. Unless if you have something that you want help on, email it to me right now. If not, you should be either working on any past homework or like the homework that's due today or the unit test, right? That's the next hurdle that we're trying to get over so we can dive into the next section. Huh? I forget. Let me check. I know that might sound weird that your teacher's like, I don't know what we're learning next, but I have to keep track of like too many different classes in too many different places. I know my Math 2 class is learning trigonometry next. Oh, from 311. Yeah, I see it now. Sorry, you got blocked by another email from another student that made my brain think it was the same. Thank you for calling me on that. I appreciate that. Like, seriously. I know it's still kind of weird, and you guys had the weirdest start to the school year ever to, like, try to get used to us as teachers, but I really do appreciate when you guys, yes, even like 12-year-olds, tell me, hey, no, you're wrong. Like, I like being told that I'm wrong because I don't want to be wrong. So if I say, I don't have any emails, and Adam's like, yes, you do. All right, so before I scooch this up so we can see it, the illustration below shows the graph y as a function of x. It says this is a function. To me, it looks like a bike ramp, but okay. So complete the following sentence based on the graph. Initially, as x increases, y... What does the drop down actually give you the option? So initially. So let me teach you guys some more vocab that you don't need to know yet, but we might as well talk about. Domain stands for the x amount or the input of the situation. So our first domain region here is this section before the behavior changes. So there's like 4 different domains here. There's the domain that stops here. There's the domain that stops here, the domain that stops here, and the domain that keeps going the rest of the way. So in the first domain, what is happening to y? It's constant, because it's not changing. Y is staying at 0. So initially, y is a constant. But then, afterward, the slope of the graph of the function is equal to, rise over run, 2 looks correct. Then, the slope of the graph, well, now we're going down here. -1. And then the greatest value of y, the highest y gets. What is the y? It's 4. And that occurs when x was 5. Very good, very good. We should review this because I feel like some people have forgotten. I changed it. What is the lowest percent that you can get without needing to just like talk with me? 80. We made it 80 now. Now, really, what I said before break was 78 can slide on assignments that actually, like, I forget how many, I think it's a 7 question assignment. Gravity works. That used to happen over in Phoenix all the time. But notice on most of my posters I've tacked up using like pins. It's because you guys don't care. I'm not allowed to like mess up this classroom because it's not my classroom permanently. So if I mess up the walls, I'll be in trouble. Which I don't really care if I get in trouble, but I'm sorry. Do you want to go grab a Chromebook from Miss Alley's room? Crap, what were we saying? Oh, so guys, we bumped it down from 85 down to 80, but a 78% I will let slide. If you're stuck any lower than that, meet with me. Talk with me about why you can't get to that higher score. What, the fact that she's on the screen? Whatever. Doesn't matter. Next for you guys, after linear equations and functions, we're gonna go ahead and stop this.